Hey, welcome. Today we're going to be talking about how to convert numbers from decimal numbers to binary numbers. So fundamentally we're going from a base 10 system to a base 2 system. And I'm going to show you how to do this with two different methods. So let's go ahead and get to it. We're going to start with a number 89, like our regular base 10 number 89, and say, well, how would we convert this into a binary number? This is another way that you'll see this in problems in terms of how they are written. And one of the first things we want to do is start thinking about powers of 2. So 2 to the 0 power, we'll get to that in a moment. 2 to the first would be 2, 2 to the second, 4, 2 to the third, 8, 2 to the fourth, 16, 2 to the fifth, 32, 2 to the sixth, 64, and 2 to the seventh, 128. So if you don't know that off the top of your head, that's okay. That's what a calculator can help you with. But if you get in the habit of learning that, then that would be helpful for these kinds of problems. Now I do want to talk about 2 to the 0 power. I have proven that anything to the 0 power is 1. And I've proven why that is in a previous screencast on the opposite conversion problem, so going from binary to decimal. So I'll put a link to that in the upper right about now, so take a look if you like. But basically anything to the 0 power is going to be 1. And so we want to take this number and break it down into powers of 2. First method I'm going to show you, the subtraction method. We're going to start with 89 and we'll think about where 89 falls. 89 falls right here in between this power here, 2 to the 7th and 2 to the 6th. So it's not all the way to 128, so we're going to pick the one that's beneath it. So we have a full 2 to the 6th power in this as well as some other stuff. So that full 2 to the 6th power we're going to represent with a 1 right here for now in this location. And we're going to say, well, let's subtract 64 because we're trying to take this and break it down into pieces until we can fully represent it with some ones and zeros here. Alright, so we have 64, so we think to ourselves, alright, there's 25 left. So what would we use next? Like, what's the next full power of 2 that we have that would help us to break down 25 further? 25 is in between these two numbers, so would we use the 32 or the 16? What do you think? Well, we're going to use the 16. We have to use the lower number because that fully represents part of this scenario. 32 would be overreach. So we would say, all right, well, let's take that 25 and we're going to subtract 16. So I put a 1 right here to show we're representing part of that whole number of 89 into pieces of 2 to something powers. So I've got that 1 over here. I do the subtraction problem and I end up with 9. So where's the next one that I write down? Well, 9 falls in between 16 and 8, so we cannot use the 16, so we have to use the 8. Let's go ahead and write a number 1 here, so we're going to say 9 minus 8 is equal to 1. So we've got one more thing to write, and that is this 1 over here is exactly what we're looking for. So I'm going to write a number 1 right here. And that's it. And then you say, well, what do we have if we don't have ones? What are we left with in a binary system? Well, we're left with zeros. So binary is represented typically by ones or zeros, high voltage, low voltage, but in computer code it's represented by ones and zeros, and computers can deal with that very easily. So what we're going to have are just zeros here for the fillers for the ones that we did not put a number with, and that's going to be our answer. So I'm going to put a box around that, and that was our first example using the subtraction method. Let me show you a second example using the subtraction method. So let's say we're going to use 132. I'll go through this more quickly this time. 132 is just over here. The doubling of this would be 256. So 2 to the 8th would be 256 over here. So we don't go that far. We do need to put a 1 right here to represent 1 times 2 to the 7th. So I will do that with that one. We'll say let's take that 132, subtract 128. That gives us 4. What do we need? Well, we need a 1 over here in this location to be able to subtract out that 4. And that takes the entire problem for us. What do we have left over? Well, we have a bunch of zeros, so let's go ahead and put in those zeros. And this is going to be the binary representation of 132. So that's how you would use the subtraction method. Now what I want to do is show you a second method, which is the division method. We're going to use the same two examples and show you a different way of solving for this. So this is our answer previously. We start with 89 and we're going to convert that to a binary number. Now instead of doing subtraction, we're going to do successive divisions by 2. So we could say 89 divided by 2. What is that? Well, you could say, well, I know 88 divided by 2 would be 44. So it'd be 44 with a remainder of 1. That's how we would write this. All right, then we take this number, we'll write it over here and divide it by 2. So 44 divided by 2, what would that be? Well, that would be 22, right, with a remainder of 0. And we take this number, bring it over here, and we say, all right, 22 divided by 2, well, that would be 11 with a remainder of 0. 11 divided by 2 would be 5 with a remainder of 1. And 5 divided by 2 would be 2 with a remainder of 1. And 2 divided by 2 would be, well, that's 1, right, with a remainder of 0. And then this is a little bit tough, but 1 divided by 2, you could say, well, that's a half. But how many full 2's go into 1? Well, there are 0 full 2's that go into 1, you could say, but it has a remainder of 1. All right, so these are our numbers right here that we're dealing with. The very last one is the most significant bit. We're going to focus on that one as our most significant bit. And the very first answer we had up here was the least significant bit. So what we're going to do is we're going to box this as our answer, and check this out. If we read it from the most significant bit to the least significant bit, we have the same answer as before. So we have 1011001. So this checks out. In other words, this method gives us the correct answer, just like our subtraction method before did previously. All right, well, let's see how this works out with our second example that we had worked on. So 132, this is the answer we got with the subtraction method. Let's go ahead and use the division method. So 132 divided by 2. Let's think about what that would be. That would be 66 with a remainder of 0. 66 divided by 2 would be 33 with a remainder of 0. And 33 divided by 2, well, I could divide 32 by 2, and that would be 16 with a remainder of 1. 16 divided by 2, well, that's easy. That's going to be 8 with a remainder of 0. 8 divided by 2, that's even easier. That's going to be 4, remainder of 0, and so on. You keep going down here. This last step, that's going to be 0 with a remainder of 1. So you take a look at this. This is going to be your most significant bit down here, your least significant bit up top, and you put them in that order. So 1, 0, 0, 0, 0, 1, 0, 0, which is the same as what we got previously. So hopefully this has been helpful. I go through basically an entire year of physics concepts, so if you want to see more videos, you can subscribe, or you can take a look at the channel, and I'll put a link in the description for this unit as we deal with electronic communication ideas. Take care and have a great day.